So Star Trek is an extremely popular TV and movie series with so much cool futuristic technology that scientists are actually working on recreating now. The two main futuristic technologies that I will be focusing on in this video are force fields and teleportation. First, force fields. The most promising technology that we currently have that might lead us to something similar to the force fields we see in Star Trek are something called plasma windows. Plasma windows were first invented in 1995, and they're basically just a layer of plasma. This plasma can actually create a vacuum because the plasma molecules exert a pressure that stops air from rushing in. So what is a plasma really? We all know about solids, liquids, and gases. Each are composed of tiny atoms that are vibrating faster and faster as you get to the different states of matter, but a plasma is the fourth state of matter. In this state, the atoms are vibrating so fast that the electrons rip apart from the rest of the atom. You can see plasmas in everyday life in things like lightning or even neon lights. Now, a plasma window alone would not be strong enough to make a force field, but it would definitely be a huge contributing factor to something that would act similarly to a force field. If a plasma window was combined with many other substances, such as high-energy laser beams that can vaporize objects, a carbon nanotube lattice, and photochromatic technology that can deflect laser beams, you could potentially create a force field that is very similar to the ones you would see in Star Trek. Now next, let's move on to teleportation. This is slightly more complicated than force fields, but it's not impossible. Before we get into the physics of teleportation, let's talk about the difference between Newtonian theory and quantum theory. In Newtonian theory, teleportation is impossible because it assumes that all matter is composed of tiny hard balls that are unable to disappear and reappear on their own. Quantum theory, however, is slightly more complicated. In quantum theory, electrons act as waves and can actually make quantum leaps within an atom, which is when they disappear and reappear at the other end of the atom. So teleportation does happen on the atomic level with electrons, but this movement averages out so that the objects appear solid and permanent. Now the question is, can we use this same kind of quantum teleportation to apply to larger objects, maybe even humans? The most researched form of man-made teleportation is quantum teleportation, which relies on an idea called quantum entanglement. Quantum entanglement is when two particles are vibrating in coherence because there is some deep connection linking them together. So if you know the spin of one electron, you can instantly know the spin of another entangled electron, and you can even know this information faster than the speed of light. So if our electrons happen to be entangled with electrons in some far-off corner of the universe, whatever happens to our electrons will automatically affect those electrons. Scientists have been trying to use this concept of quantum entanglement to teleport objects like photons and atoms. To do this, we first need two atoms. Let's call them A and C. Now we also need a third atom, let's call it B, that's already entangled with C. Now when A scans B and transfers its information to B, this information is automatically transferred to atom C because B and C are already entangled. Now the information that was in atom A has been transferred to atom C, which could be in a totally different place. Using this method, in 1997, scientists were able to teleport photons of ultraviolet light. Then, in 2004, scientists were even able to teleport particles of light over 600 meters using a fiber optic cable. Later in 2004, this quantum entanglement method was used to teleport beryllium atoms. And in 2006, scientists even managed to teleport a gas of cesium atoms, which is made of trillions of atoms. In 2007, a new form of teleportation was proposed, which didn't involve quantum entanglement. It was called classical teleportation. Using this new method, scientists took a beam of rubidium atoms, converted the information into a beam of light, transferred the beam of light over a fiber optic cable, and then reconstructed the rubidium atoms at the new location. In order for this method to work, scientists need something called a Bose-Einstein concentrate, or BEC. BECs are one of the coldest substances in the universe, a millionth to a billionth degree above absolute zero, and they've only been found to exist in the laboratory. When matter is cooled to near absolute zero, all of the atoms go to their lowest energy state, which causes them all to vibrate in coherence. So if you start with this super cold BEC and then you apply the rubidium atoms to it, all of the rubidium atoms will tumble to their lowest energy state, causing them all to vibrate in coherence. As they tumble down to their lowest energy state, they will emit their excess energy as light. And this light beam will contain all the information needed to reconstruct the rubidium atoms. They would have the positions and the velocities of all the atoms. So when this light beam hits another BEC, it would convert it into the original matter that we wanted to teleport. So scientists are using both of these methods, quantum teleportation and classical teleportation, to research how we can use this for larger objects. Right now, they're working on teleporting viruses and DNA, but maybe someday in the future, it could even be humans. So in conclusion, these technologies actually are possible, and they're things that scientists are currently working on. plasma windows may make force fields possible, and quantum teleportation and classical teleportation could make the kind of teleportation we see in Star Trek possible. It's just going to take a long time to figure out how to scale up this technology to the size of humans. So keep an eye out on the news in the scientific community, and maybe soon we'll be battling aliens and traversing the universe like Spock and Captain Kirk.